Uh, there we go. All right. Now, before we get started, I want to give a big shout out and a thank you to our sponsor, Vaco, specifically Spinman at Vaco. He has supported us since, I believe, 2019. So he's been with us for a good while. And just excited to continue that relationship this year. If you live in Nashville and you're listening to this, reach out to Spinman. If you aren't on BurrowDev Slack, then you can join by going to burrow.dev. We have a link there. You can submit a form and I will see that personally. We have to filter all our invites now because we kept getting spammers. The bigger that our group gets, the more that's going to be a problem. So you see that link, the URL is forms. It's just a Google form. You fill that out. I try to respond to those within 24 hours, and then you'll be invited. All right. I think that's it for our sponsors, and I'm going to let you take it over from here, Dustin. You can go ahead and do a short blurb about yourself, introduce yourself, because not everybody knows you here. So let's start off with that.
Excellent. Thanks, Sean. Well, good evening, everyone. Name's Dustin Korzaan. I'm bringing to you tonight just a high-level introduction to Azure Service Bus, Azure Functions, and Azure Blob Storage. And I say high-level, it is definitely high-level. What I'd like to do is introduce the three very lightly, but then try to bring to life a simple use case. And to do so with those three, we have to move pretty quickly through those. First, just about myself a little bit. Beautiful wife of 22 going on 23 years, Dr. Melinda Korzaan. She's a faculty member here at MTSU. I have 2 horses, and just this December got a new dog, Indy. She is a 6-month-old mix, and so we're adjusting to that. So professionally, I do live in the Murfreesboro area. We've been here since 2004. Currently been with Schneider Electric for 2 years as a senior developer, delivering solutions that help our project managers deliver products and services to our customers. A little bit about the unit that I'm in at Schneider Electric. We're doing all things energy. So if you think of schools, if you think of hospitals, if you think of government buildings, we go in and renovate everything energy, from water to lights, etc. And not only do we renovate, but then we also monitor and deliver a warranty with that to save money over the next 15 years. In addition to being a developer at Schneider Electric, currently engaged with Ackland Avenue, their Nashville-based development team. They have some nearshore developers in Honduras, which comprise the majority of their development that they do with us in a partnership. So shout out to them. All right, so tonight, as I mentioned, 3 really quick topics: Azure Service Bus, Azure Functions, and Azure Blob Storage. We'll probably talk a little bit about Service Bus, very little bit about Functions and Blob Storage. We'll just more see those in action. Really want to get to a simple use case. So in the trial recording of this, it was an hour and a half, so I think I've cut it down enough. Hopefully we can get this in the next hour. So here we go. I'm going to start at the end, and it is, what's our simple use case? Well, our simple use case, I need to pause for a second, because one of the things I want to do tonight is create everything live. So one of the things I need to do is I need to create a Blob storage account so that it has 5-10 minutes to show up in Azure. So I'm in Azure portal at portal.azure.com. I need a storage account. This allows me to store Blob files. And real quick, we'll create a group. We're going to call this Burrow Dev Resource Group. We will create a Burrow Dev Storage, and it all has to be lowercase. I tend to use East, US, and I like geo-redundant storage. There's always more information about all these type of options on Azure's documentation, but those are some quick preferences that I personally like to use. We'll hit review, we'll hit create, and let this do its thing. It only takes a couple minutes for it to generate, but it takes about 5-10 minutes for it to show up in a couple other places. So back to our presentation. My simple use case is I have externally hosted applications that need to send internal email. The reason I need to send internal email is this is the only internal email relay server that I am granted access to use. It is on a private network, so I cannot access it from an external network, which actually in a lot of ways is good. In my scenario, I have some publicly hosted applications. Both the API and the UI are all hosted in Azure Cloud. They're external facing. There's nothing internal about these applications. Well, these applications cannot in any way connect to this internal email relay. So what we're going to do is we're going to look at a couple different ways we can deliver this. First is we're going to look at Azure Service Bus here in a minute. We could actually have these apps send messages to a worker internally. This worker internally could then actually send the email through the mail relay. We can't do this because of message size. Azure Service Bus only allows you to have messages of 256 kilobytes on their standard plan. Their premium plan allows 1 megabyte, but you still don't want to consider that. The reason you want to consider is message size is a big problem with Service Bus because you only have a limited queue size. So you always want to keep these ultra small. All right, so the next option we're going to talk about tonight is Blob Storage. Blob Storage allows our apps to be able to store binary. You can store strings, you can store images, you can store anything in Blob. What's great about Blob is you don't have the size restrictions. You aren't limited on your file size. It's cloud-based, it's scalable, it's highly performant. So we could actually have our applications just write an email to Blob Storage and let somewhere along the lines a worker internally on our private network could come out, pull this Blob Storage for emails. That would work, but we don't like polling because if I create an email, I'd like to go now. I would like to not have to wait 5-10 minutes for a polling service to pick it up. So what we're going to look at is 2 more options. The next one is we could actually have these apps store the image or the email in Blob Storage, immediately turn around and send a message over Message Bus just saying, hey, go pick up this blob file. The worker, of course, could then go to Blob Storage, pick up that file, deliver it, and delete it from Blob Storage. Great. Reason I don't want to do this is I then have this app responsible for 2 things. 1, have to create the blob, drop it in Blob Storage, and 2, has to have a connection string to a service bus and send that. So what do I want to do? Well, what we're going to do is we're going to use the last piece we're going to put in this puzzle is Azure Function. Azure Function is built into Azure's cloud solutions to where it can respond to events. And the one we're going to wire into today is a Blob Trigger. What's that mean? Well, what that means is as an app writes a blob to Blob Storage, Blob will actually trigger an Azure function. This Azure function can send a service bus message. Our internal worker can be subscribed to this message bus and receive this message. At that point, this worker will know which blob was just written and needs to be sent out, so it can go to Blob Storage, get that, deserialize it, send the email. This is what we're going to build. We're going to build it backwards. If we run out of time, we may not make it all the way to the apps. But what we're going to do is we're going to start just with Service Bus. We're going to talk about a sender sending messages to a worker. Once we get that working, we'll then create an Azure function. It will send messages to the worker. And last, we will create a Blob Storage account that When blobs are uploaded into Blob Storage, it will trigger the Azure function, thus sending a message to the worker to get the email and send it. Sounds like a roundabout way to do it, but architecturally, this gives us insight to these three components, and that is Service Bus, Azure Function, and Blob Storage in a simple use case. All right, so again, our three topics we talked about our simple use case. What I'd like to do is we're going to kind of glaze over the Azure Introduction Day for time, but please check out, there's many resources out there that give introductory videos to what Azure is. The focus is, of course, on cloud computing. It's globally distributed. You can scale up, meaning your web server can have more horsepower, and you can scale out, meaning you can have thousands of web servers. And then ultimately, it's pay as you go. You can have contracts that have different maintenance and different rates, etc. But ultimately, the model starts with a pay as you go. The two URLs to remember is portal.azure.com. And last is the status.azure.com. Believe it or not, it does turn red every so often. It's turned red twice this year already. I think we had a DNS issue. They had a DNS issue, and I can't recall what the other one was. So when you're doing product development, know that we're not having to worry about infrastructure, but the infrastructure still has a hiccup here and there. All right, Azure Service Bus, just the simple concept, we are going to do messaging. It allows us to decouple our applications. As you saw in the diagram earlier, our application doesn't have to understand what's going on with the other applications. It just needs to either write a blob file, send a message, something like that. Uses AMQP, which is an open standard. And the one thing I'd highly recommend you research before using Service Bus is dead letter queue. Dead letter queue is the concept that somebody's queued a message or an app is queued a message and a worker never picked it up before it expired. And so if your architecture has built in it an assumption or an expectation that a message will get from point A to point B for part of your process, dead letter queue is something that's important to understand. All right, so here's some examples from Microsoft. What is a service bus? Well, a sender sends a message into a queue. A receiver picks them off one at a time. Straightforward. Another image from Microsoft's site is you have messages coming into queue, but you have multiple workers picking them off one at a time. We'll see this in action here in a minute. The other scenario, of course, is you have multiple senders, like multiple web apps, mobile apps, websites, etc., sending a message to a queue. Your receivers pick them off one at a time. So this is a queue. A very different concept is a topic. Service Bus has a topic and a subscription, and subscriptions in contrast to queues. What happens with a topic and a subscription is for each message sent, each receiver receives a copy of it. So each receiver in this diagram is a subscriber to their copy of every message that comes through the queue. One of the diagrams from Microsoft's site talks about messages that go to like multiple stores. Every store gets to hear about every order, but they only respond to the orders that pertain to them. I'm not going to go any deeper into topics and subscriptions. Our focus tonight is using a queue. All right, so back to our workflow. Our first focus here is the worker. We have a service bus that is going to receive incoming messages. We're going to have a worker subscribe to those messages. So for a demo, we already created our Azure Blob Storage account. I need to pause for a second. I need to create an Azure function, and then we'll get back to Service Bus in just a second. So I'm going to go create an Azure function called Function App 1. Sounds great. We're going to create an HTTP trigger. This is what triggers the function. And I need to publish this function. So just a moment here, NuGet restored publish. We're going to publish to Azure Function App. We are going to create a new function app. We're going to call it Function App Burrow Dev, Visual Studio Presenter. The consumption type allows it to scale quickly. From a resource group, we'll put it in our Burrow Dev resource group. For storage, we'll use our Burrow Dev storage that we created preemptively earlier. For that, that's what the function app runs on top of for its to manage itself. So we're going to hit create. That's going. While that's going, we are going to move on to right back to Service Bus. What do we need to do Service Bus? We need a standard account. We need a console app that's a sender and a receiver. To do this, we go to our Azure portal. We go to Service Bus. We create a new Service Bus. We will we'll use our Burrow Dev resource group. We'll call this Burrow Dev Service Bus. I am going to create this in the East US again. And from a pricing tier perspective, I've only used standard. I've never had any performance issues. From a pricing perspective, we'll see that it's $10 a month, whereas the premium is $668 a month. Both pricing plans support queues and topics, so there's no limitation for us to pick the standard. Standard East, Burrow Dev, next, and create. So I'm creating these accounts in my MSDN account. They give $50 a month for me to play with for things, demos like this, testing, etc. And so this gives us just enough to be able to set up these services, test them out, present them, etc. All right, well, that finishes creating. On our slide, we talked about we need a sender and a receiver. For my sender, I'm going to create a console app. I'm going to call this Burrow Dev Sender. Next. .NET 5, create. For my receiver, I'm going to create something called a worker service. .NET Core came out with the worker service formally in .NET Core 3. Highly recommend you use it if you are doing anything that's a running process, like a background process. With the addition of one NuGet package, it can become a backend service, a Windows service. So we will call this Burrow Dev Receiver. We'll do it on .NET 5. All right, so we have our receiver. Our receiver has a worker. Our worker is where we will do our work. If we go over to our sender is a console app, and that's where we will send the messages. All right, let's see if we have everything. We have an Azure Service Bus standard account, a sender, receiver. What's next? We are going to now again do the sender to Service Bus to a worker. What I'm going to use actually feels like cheating, but we're going to go to Microsoft's demo, example, hello world. We are just going to grab the first half of their script, which does a connect to service bus, send a message. What we want to do is paste that into our code and utilize it. What we'll do is we'll go over to Azure portal. We created our service bus. If we go to the resource, there's a shared access policy. This will give us access to keys that allow us to connect. I'm going to grab this primary connection string. What this allows me to do is I now have a connection string to connect to this Azure Service Bus. As for queue name, I don't have a queue name. If we go down here, we have queues, and we also talked about topics. Tonight, we're going to create a queue. We're going to call this Burrow Dev Queue. Size, I tend to always make these 5 gigabytes. I tend to retrain 10 times sounds great. Keep the message for up to 14 days before, as we mentioned, dead lettering. And for tonight's demo, we're going to up this to 1 minute instead of a 30-second timeout. I just find that sometimes 30 seconds is not enough to illustrate some things. But there's all kinds of other settings on here where you can enable duplicate detection. You can actually formally define the dead lettering. Partitioning is a whole nother subject in sessions, but we will keep it focused on these initial settings right now. So Burrow Dev is our queue. We will create it. So now our Service Bus account has a queue of Burrow Dev queue. In our Visual Studio sender, we can send a message using our connection string and our queue name to this client. Before it can work, we have to install some NuGet packages. What we do here, we go to NuGet package store, and we want to be careful to actually pick the right one. SDKs are interesting because they come out with multiple. There's Microsoft Azure Service Bus, there's Azure Messaging Service Bus. This stopped at version 5, this is at version 7. So various SDKs, various examples out there. You want to make sure you have the right SDK to match, of course, the example that you're working with. So if we look at this, we have messaging.service bus is what we want. We will search our NuGet package for messaging.service bus. That's Windows. I always get the wrong one. This should be a simple thing because there's 14 different permutations. So there we are, Azure Messaging Service Bus. It's version 7. It's the latest. It was published 2021. We'll install that. Now that we have that package installed, we can add a reference. And we can make our method async. Now that we have clean code, this connects. It initializes a client. It establishes a sender. It builds a message. The message, all it literally says is hello world, and it sends the message. We're going to get rid of our old console statement, and we can run this. And at this point, it will connect to Azure. It will send a message, and it will disconnect and end the program. That's it for our sender. The other half of this, we will go over to our receiver that we set up. A little different. I did a worker. Why? Because that's where we're going. It's not the best for this example, but it will get us to where we're going. Again, if we go over to these Microsoft 101 examples, what we're going to do is copy everything, but we're really interested in the receiver this time. So what we'll do here is we need a connection string queue name, client, sender we don't need, message we don't need, send we don't need. In this case, we're only focused on the receiver and the receiver message. At the end, once we get the message, we just want to write it to the console. Again, we have to go to NuGet Package Manager. We have to go to Browse, Azure.messaging.service bus, version 7, install. Okay, okay. And at this point, we can get some using statements for this. We need a connection string. I'm going to just switch back to our sender, look at our code, copy our queue name and connection string into here. If we run this, we should see a hello world message come through. We see hello world, great. It worked as it should. If we noticed earlier, our sender program shut down. It disconnected. That message was in Service Bus waiting for a receiver to pick it up. What I'd like to do is go back to the sender. We'll hit run one more time. It will send a message. We're going to find two things interesting here. We're going to go back to Azure Portal. We're going to go into the queue. We're going to look at, they have an Explorer in here. This allows us to peek at the messages. Two interesting things. One is you can peek at the message, and what's also interesting is there's two messages. We sent one, we received one, but now we've sent the second one, but we have not received the second one, but there's still two active messages. We'll see why here in just a second, but here if you click on each of the messages, you can actually see the message over here. It's string in this case, so you can actually visually see it. But there's still two messages. So let's go over to our receiver. I want to run it again. We're going to run it a couple times actually. We can see hello world came through. I'm going to run it again, and we're going to see hello world came through again. So now we've received three messages. Rerun it again, and now it's stuck. It's stuck because the code that we copied in from the hello world is written in a way that says, go to Azure Service Bus and receive a message. And it just sits there and waits, and your code is stuck. This isn't good. It's not best practice. So one is we're going to switch away from this. But before we do, there's one thing we probably want to copy in here from. So if you scroll on down in the hello world or in the additional examples, once you get a message, once you do what you want to with that message, you have to mark the message complete. Marking the message complete is the code telling Service Bus, I've not only received the message, but I've processed it. You may now delete the message. So there is a handshake there. We know for sure that a worker received it, and it says that it fully processed the message. So let's rerun this, and we should now get like a couple messages again. There's hello world again. Let's run it again. And it's sitting there stuck. Let's go look at the message queue. If we refresh this, we are down to one message. The reason we're down to one message is we processed one of the messages within a minute ago. So whenever that minute expires, it's actually going to resend the message again, and we'll see it. So what's interesting is you see this pulling the message multiple times. You think, wow, this is unreliable because it's sending the message over and over again. Well, this is one of the things about Message Bus. You have to set it up to your needs. Here we just saw our hello world come through again. At this point, we probably have 0. So earlier, when we created a queue, we set up a, let's see if we can go back there and look at this. BroDev queue. we had some settings on here. This is not scripted. Properties, locks, tasks. It's in here somewhere. I've tweaked them before. It's a little different whenever you're looking at a small screen. Resource subscriptions. All right, so you can actually go in here and change the settings on your queue. I thought it was in properties, but it's not. So the timeout, we said 10 minutes. That's an important aspect of when you receive a message, you have a certain period of time to process it. 14 days, after 14 days, if it goes away, it goes away. It goes to a dead letter. All right, so we're receiving messages. Now there's a couple more things I don't like here. First is on our sender, we're actually sending hello world. Real world, the hope is to never send an actual just text. Always send a model. Always send something that has a model in it. The reason is the only change in IT is everything, the only constant in IT is everything changes continually. So today we may be just sending a message that says hello world, but tomorrow we may have additional properties that we need to do, like hello world, and we need to say who it's from. Well, if we've built a model, we just add an additional property. If you've just literally sent the word hello world, you have to literally rewrite all your applications to be able to migrate from your current configuration to your new configuration. So definitely try to always use models, even though it's just a message string. By using this model, if we send one more message, we should see hello world get queued. And then if we go over to our receiver, we should see hello world come through, but it'll look just a little bit different. Here we see a JSON object of message, hello world with a timestamp. So at least it's a model. All right, next slide. What we're going to do on our next slide is we are going to now start working towards our solution. But before we do, we want to get our receiver working a little better. I mentioned that it stops. We don't like that it stops, and the reason is it's this line of code receiving a message is literally just stopping and waiting. Instead, what we're going to do is we're going to copy in just a little bit different example. And what we do here is we still need a client, but what we do is we create a service bus property option where we say autocomplete false, maximum concurrent calls 1. We create a processor for our queue name, and we wire up 2 events to it, a message handler and an error handler. We start processing. We delete everything else. Now, I said there was a message handler, error handler. We'll copy those in also. They are methods. We'll put them in here. The message handler simply takes arguments of a message event where we can pull our body from it, just like we did earlier. We can write it to a log. This will be our console. And then, like we mentioned earlier, we can complete the message. Last, we have an error handler that we just log errors. Let's hit run on this. What's different about this now is we have a receiver that runs, and once it finishes wiring up the receiver, the worker service just sits there and polls. I'm going to make this 5 seconds, just 1 second's a little too much. It just sits there and stays running while those events are wired up, waiting for messages to come through. So I'm going to keep this on the right side of the screen. Let's run our sender. We're going to run our sender a couple times. We'll notice on the right, we should have a message come through. We did. we can run it again, and we can run it again, and we can see each time we're seeing a message come through. Well, to make our sender a little more interesting, we're going to wrap it with a for each loop. This send message, we'll wrap it with a for each loop, thus getting about 10 messages for each run. So if we run this, now the sender's on the left, the receiver's on the right. Each time I press enter key, it's going to send 10 messages. On the right, we see 10 messages showing up. So what we have here is every time I'm hitting enter, 10 messages is queued in the cloud, and this receiver over here says, hey, I'm ready for some new messages. They come over. We can see the numbers here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. What's fun about this is we can actually go over to our code, receiver, bin, debug, .NET 5, and we can simulate having multiple workers. So we can run, in this case, we will run 3 receivers. And this would be the start of thinking about scaling things in Azure. So if we have 3 workers running, each time I send 10 messages, we'll notice that each receiver processes 4 or 3 messages. So I will send, 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 and we can tell the messages by, you can see ID 3, 6, and 9. Here we had 1, 4, and 8. Here we had 2, 5, and 7. So each receiver is, it feels like round robin, but it's not truly round robin. It's whichever receiver is ready for a message next gets the next message to work on it. All right, so that's it for the receiver. Let's move on. What we just did is we didn't look at max concurrent calls, but look it up. What that does is it allows your worker, each worker, to have multiple messages at once. We did look at one-to-one, meaning one sender to one receiver. And then we also just here last looked at one sender to multiple receivers or workers. All right, so back to our model. We have the first piece, we have our worker. Our worker is our receiver. We have Service Bus, it's wired up. Now we have a little console over here that's a sender, but we don't have an Azure Function yet. Let's see, I think that's next. Next is an Azure Function. An Azure Function is what feels a lot like is an app service or a traditional .NET website hosted on IIS, but it's cloud-based. Why would we use Azure Function? It's scalable. It has this event-driven type concept. It also really starts making us think of microservices, writing little services to complete a small unit of work. Last, of course, it is has multi-language support, platform support. So what we did a moment ago, out of order a little bit, is we created an Azure Function. We literally went into Visual Studio. We said File, New, Azure Function. We said we wanted to publish it to Azure as is. We created an app service, or in this case, a function app. I don't like to check package file, finish. And at this point, we have a little function app that if we publish this to Azure, we will be able to run the default. The default was an HTTP trigger. So let's let this build. While it builds, we'll go out here to Azure. We'll notice under function apps, we now have a function app. we go in there, if we look under functions, we'll see that, do we have a function yet? Maybe, maybe not. Yep, it's already there. And it's HTTP function. If we click on it, one of the things Azure Function apps do is they provide some built-in security to where you can actually not have to manage your endpoint security if you're doing like some application-to-application development. Let's go back here. I don't think it was quite there yet. Click on function and get function URL. If we copy this URL, it's literally the function burrow-dev./API/function1. Now, additionally, it also has a code on it, and that's the security token. This little demo welcome app has a thing. If you send in name, it will say, hello, Dustin. If we send in burrow dev, it'll say, hello, burrow dev. So that's it for our sample function app. What we literally did was in Visual Studio, we said file, new project, function app. He created this function app that supports a get and a post, function level security. It responds to query string, has a body, and it sends an HTTP response string. All right, so that's our sample function app. What we're going to do is we're going to delete the function. We're not going to use this function. Instead, this is where we want to talk about a function app has the ability to trigger from Blob Storage. In our diagram, we want a function app to be triggered by Blob Storage. If we go, we can create an Azure function. There's all kinds of different ways you can trigger an Azure function. The first that we already saw was a HTTP trigger. Tonight, what we want to do is a Blob Trigger. We want to use, apologize, I need to copy. In app settings, the connection string is Azure Web Jobs Storage. I needed to copy that. All right, so add new function, Azure function. In this case, we're going to pick a blob trigger based on our connection string. And tonight, we're going to call this internal email. This is our container name. More on exactly what that is later when we talk about Blob Storage. But what we're doing here is we're creating an Azure function that's triggered by Blob Storage. So anything that's put in the container internal email / whatever will trigger it. Well, we want to clarify this with outbox / name and dot. We're going to do a JSON file. What's this mean? Well, anytime a file is written to a folder outbox JSON, the name will come through on this function. It uses our connection string, and here we can get the name of the file that was just uploaded. This function, if we publish it right now, won't do anything. It'll just log what happened. Let's rename this function. Let's call it blob. Let's call it our email blob trigger. And we'll rename the class just so it looks a little more meaningful. What we'll do now is we will copy in some code. We are going to copy in basically the exact same sender code that we used just a minute ago. You'll notice connection string queue name, client, sender, message bus, JSON, where we encode. We're going to encode as blob name instead of what did we do with hello world? Message. So here we get a message. We're going to take this JSON and we're going to send it to Service Bus. That's it for our function. What I'll do is I'll go over to our sender. I'll copy our connection strings. So exact same code to show that Azure functions are a lot like .NET applications. You'll notice we have to go to NuGet the same way. Azure Messaging Service Bus. We're going to install 7.1. And we can make everything async. Service bus message. We may have gotten the wrong Azure Messaging Service Bus. That looks right. Missing a class here. Here's my class. I brought in a class, just a simple class, because it's better to have it type-based than generic. So Service Bus is our SB message, is our message. Property name is blob name. So here you can see we are going to send a message where we say blob name is equal to outbox/name.json. Same pattern we see up here, outbox/name.json. All right, so one more reference, sorry. There we are. So we have an Azure function that will respond to a Blob Trigger. It will then connect to Service Bus. It will send a message indicating which file was just uploaded. And that's it. Well, let's hit publish again. We'll say publish to Azure. Now that we have this published, we should note that we have a worker, we have Service Bus, we just published an Azure Function Blob Trigger. Let's take just a quick look at Blob Storage. There's a couple links in here. We'll share the PowerPoint, but quick start for Blob Storage. Again, there's SDKs for it. Make sure you're using version 12. Version 12, nice simple NuGet package. It has a blob connection string. This may kind of sound familiar. It also has a client, and then it has a blob client when it actually goes to grab a blob file. Lots of good information out here. Once you have done a few of these where you've just written these out in verbose, then you'll probably, of course, want to abstract it out into some type of interface class, and that should provide you what you need. All right, let's see. We've published our function. Our function's in the cloud. It's waiting on us to actually write some files to it. Here we talked about our connection string to Service Bus. One of the things we are leveraging is that this Azure function is already connected to Blob Storage. This internal email, this is a container. So let's go to our Azure portal. In our Azure portal, the first thing we created tonight was a storage account. We see Burrow Dev Storage. In there, the main thing that I've always used in here is containers. Here's containers. There's a couple already in here, logging, and a couple for Azure Functions to host itself. We want to create a new container called internal email that's private. We will create it. And inside of this internal email, we are going to stop in the web portal. We could actually upload files here. There's another tool that you'll want to research, and it's in the PowerPoint, and it is called Microsoft Azure Storage Explorer. The reason we created the storage account earlier is it takes about 5 to 10 minutes for new storage accounts to show up in here. As you can see here, we now see Burrow Dev Storage. Inside there, we have containers. Inside of containers, we can see our internal email that we just created on the website. For our demo, we want to create a folder. These are virtual. These don't actually exist, but we'll virtually create one called Outbox. So we're an internal email / Outbox. So if I go to my desktop, I should have a blank email that I can copy into that Outbox. When I copied that in there, the Azure Function, in theory, will see it. If the Azure Function sees it, it will send a message. If it sends a message, it'll go through Service Bus. If it goes through Service Bus, our receiver will receive it. And actually, believe it or not, everything worked the first time, so there must be something wrong. These never work the first time. I practiced it 3 times, but maybe that's part of it. So you can see here we received a message on a receiver that says a blob name in Outbox / email blank test1.json needs to be processed. All right, so what we'll do here is we'll put the Azure Storage Explorer on the right, the receiver on the left. We will copy both of these 2 emails in here. We should see 2 emails come through. Each time you write, even if you overwrite, we'll see 2 come through here. We can see our receiver internally received 2 messages. One that said process test 1 and another one said process test 2. So let's go back to our PowerPoint. What just happened is this. We still don't have an app, but we manually copied a file into Blob. That Blob file triggered an Azure function. That Azure function sent a message that our internal subscriber was able to pick up and process. It just wrote it to the console. But the majority of what we were hoping to achieve tonight is actually wired up and working. All right, so what I'd like to do is flesh out both of these, the worker a little bit, and we'll just also flesh out the app just a little bit. Let's see, next slide. Let me go back. All right, here's to flesh out the receiver just a little bit, just to make it look a little better. Receiver. So the receiver is running this code at startup. It starts up, it starts a client, it wires up 2 handlers and says, all right, processor, you go do your job, and I'm going to just sit around and wait. So when the processor gets a new message, we are actually seeing it. But now, writing a log is not what we actually want to achieve. We want to actually do something else. What we want to do, and then again, for the sake of time, I wanted to do more active live coding, but for the sake of time, we are going to copy and paste this in here. We are going to, again, want this message bus model and our email model. I was jumping ahead a little bit, but we have some classes that we want. The class we want, we looked at just earlier, that we use to send our message is this SB message with a blob name. Why that's important is we want to be able to deserialize the body that comes through. That message has something meaningful. If we deserialize it, we can get a nice message object out of it. The second thing we can do is we can actually connect to Blob Storage and download that JSON. We need a connection string. To get a connection string in Azure, we can go over to our storage account. We can go to Burrow Dev Storage. We can go to our access keys. Our access keys here look a lot like Azure Functions. If we show keys, we can grab a connection string to this storage account. By grabbing a connection string to the storage account, we've now given this application the right to connect to that Blob Storage account. We're going to connect to the internal email container. And what we're going to do is create what they call a Blob client based on that container name. And then we are going to get the blob message that our service bus message just told us to read. If that blob exists, just in case we have a timing issue, like the message got resent a couple times, we're going to download the message, which is JSON. We're going to use a stream reader to get the text from it. And we're going to deserialize it as an internal email message. What's that? It's just something made up. It's a class that I made up that looks basically exactly like an SMTP message that's built into the .NET framework. The reason I didn't use the SMTP framework's message is because it's not serializable. So I had to just create a class that looks exactly like it, so that we can serialize these messages, write them to Blob Storage, and then deserialize them when they come down to our worker. Also, it can have a list of attachments. This is kind of out of scope, but we still just need to know name and content for attachments. All right, so we have this internal email message. We're talking the receiver right now, but basically what the receiver does is when this comes in, this email message, it's able to deserialize it as an email, and it's able to tell everyone, hey, we've sent this message. We're going to just do, again, a console log here. We're not going to actually send them email tonight, but what this does is it full circle shows that we've got the content of the email inside to where it's really easy to queue up an SMTP client and send the message. Some of you might ask, well, why did we not use something like SendGrid, something cloud-based? Well, because we only have access to this internal mail relay. All right, so at this point, we have a new worker that when it receives a message, it's going to process it. So let's run it. And we're going to do one last manual test on it. So we have the receiver over here on the left. We have Blob Storage on the right. We're going to delete our test emails. And we are going to upload our test emails one more time to Blob Storage. By uploading our test emails to Blob Storage, it's going to create the trigger, sends the message. Our receiver on the left received it and said, hey, I just received this message that needs to go from, no reply, to, subject, body, etc. So let's do it one more time, but this time I'll show you for sure the content of each and we'll set a couple breakpoints. So on the right, if we look at test email 1, we literally just wrote this manually. It is a JSON object from, to, subject, body. We are literally going to copy that into Storage Explorer. We have a breakpoint on the left that broke. This is in our receiver. It says, hey, I just received something. Blob content is Outlook, email, blank, test 1. Great, all right. Let's hit F10, Does a blob exist? Yes. Let's download it. Let's get the string from it. We can see a nicely encoded string. And so it deserializes it. Now we have a nice object to work with properties, body, from, subject, to. And just for as confirmation, we are just writing the email body string. Last, we'll notice that this does go ahead and delete the blob from Blob Storage. And it completes the message in Service Bus. So we went through kind of step by step on how that receiver is processing an actual email. What's kind of confusing about this example, we're sending messages through Service Bus about emails. So don't get those too confused. All right, so the last thing we want to look at is how to actually wire this up in an application. So what we're going to do is go to Visual Studio. Let's pretend that we're doing a new .NET Core website. This is our MVC app. We are going to do next, next. All right, so we have just a simple .NET MVC app. If we look at our home controller, we'll notice we have a couple endpoints in there. There's a home index, there's a privacy. We're going to use privacy as our sender. So what we're going to do is we're going to come over here and we're going to copy and paste a new message. Again, apologize for not coding this live. But what we have here is we have our class of what we're going to send. It's an internal email. It has properties from, reply to, CC, BCC subject, body, is HTML, and our attachment information. So these are the classes we need to instantiate that we want to serialize and send over. What we do in this code up here is we need a blob service client. I think it's not going to suggest it for us. So we have to go to Manage NuGet Packages, Browse, Blob, Azure Storage Blob version 12, install, accept. All right, so now that we've installed Blob Storage, we can actually reference some using. We can make our endpoint asynchronous. All right, so what's this going to do? It's going to create a blob client. To create a blob client, we need a connection string. We did this earlier, but here on our storage account, our Bro Dev storage account, under access keys, we have an option to see our primary connection string. We'll copy that. Again, we're pasting line code. You would abstract that out to your app settings, but now we have the ability to connect to Blob Storage for the internal email container. We create a client that allows us to interact with it. And then we define a blob client for the given email that we're getting ready to send. And what I'm doing here is I'm just creating a date timestamp. You could, if you wanted to, also maybe put a GUID on there. Make it very unique. And we'll compose a nice little email. This is not for message bus. This is the email that we're going to write to Blob Storage. Again, the reason we're writing this to Blob Storage is, well, this is definitely less than 256 kilobytes. Emails can get very large very quick. We're going to use JSON convert to serialize the object to string. We'll then encode it and write it to Blob Storage using our upload client. All right, so I'll probably put some breakpoints in here so we can watch it. Let's run this. Now, this is our MVC app. This is what we're pretending is our real app that's hosted externally. It's hosted externally on a public network, has no access to our internal network. But whenever we hit the privacy tab, we want it to send an email. So it is going to send an email through our process using our internal email worker. So it hits the breakpoint. It connects to Blob Storage, creates a container client. It says, okay, let's define a blob. The blob is going to be outbox.newEmail, and let's see, blob client. You see outbox/newEmail, timestamp, and gwid.json. So here we do a new message, and we're going to serialize it, and we are going to upload it to Blob Storage, end of method. So that actually wrote a file to Blob Storage. Let's do two things. So let's leave this running. We're going to get rid of our breakpoint. On the right side of our screen, we will have our MVC app. On our left side, we'll have our receiver. So on the right side, we'll go home. We'll click privacy, and we'll wait for that message to go all the way through to our receiver on the left. And voila, our message came through. Our receiver or our worker on our internal private network received the message and was able to complete it. What I'm going to do is I'm going to stop the worker for just a moment. I'm going to go home, privacy, home, privacy, home, privacy. Well, we should notice at this point, if we go to the Storage Explorer, let me back up. Got a lot of moving parts here. Our apps, the MVC app, we just went back and forth 3 or 4 times. That should have created 3 or 4 blobs. Let's see what we have. We are going to use Azure Storage Explorer to look at Blob Storage. Internal email, outbox. We're going to hit refresh. We see 3 emails. Those 3 emails, looking at our model, should have triggered an Azure function 3 times. If we go and look at Azure, go to Home, go to Service Bus, Burrow Dev, we should see in the queue 3 messages. Burrow Dev queue. There's a Explorer option in here where we can select peek, and we can see there are 3 messages. If we actually click peek, it kind of gives us a peek into what those messages are. So message 115, 116, and 117, you'll notice each over here on the right has a message. It's a JSON object, blob name of outbox/newEmail with a timestamp and a GUID. Each one's going to be unique. You can see the unique GUID up there each time I click between these. So these 3 messages are just sitting here waiting. There is no worker picking them up. So if we go back to our worker, our receiver, and rerun our receiver, it will actually then pick up those 3 messages and send them. So Blob Storage held the body of the email message, which might be large. The actual notification to tell the worker inside to process the email. Those 3 messages sat there waiting for this internal worker to pick them up. So at this point, the internal worker was able to catch up on the emails. All right, so let's see, where are we at on time? I think we're about done. Let's see, what do we have here? We're not going to actually have time to look through this, but just kind of as an extra note, these worker services, tonight we created a service called Bureau Dev Receiver. It's a worker. And as I mentioned, this was new in .NET Core 3. This worker service allows this worker service to easily be registered inside of Windows as a Windows service. Literally, all you have to do is you have to add a NuGet package called Windows Extension Hosting Windows Services. Actually, let me at least just do that part real quick. So if we go into NuGet packages, Windows Service, here we can install the Windows service. The second thing you have to do is just tell .NET Core to use and support a Windows service in the program. So before it wires up dependency injection, you want to actually tell it to use a Windows service. At this point, if you were to compile this, you can register it as a Windows service. Literally, you just say, you run it, you can create it off a bin file, give it a username, give it credentials, go in there, hit run. That's how you can actually have the service running 24/7. Whenever the server comes up, it's there, it's connected to Service Bus, it processes messages. It doesn't have to be a console application. This is all it takes, though, to get that Windows service working. With that, I would like to thank everyone for listening to this high-level introduction to Azure Service Bus, Azure Functions, and Azure Blob Storage. It really allowed us to see how an MVC app, multiple apps, can write large data to Blob Storage, use Azure Functions, their various events to wire up a workflow, to send messages, and internal workers can pick up those and process those. If you have any questions, please let me know. That's all I have for this evening.